All right, this is Unit 5, Lesson 4, Solving Radical Equations. Our essential question is, how can you solve equations that include radicals or rational exponents? And here is our table of contents. Solve an equation with one radical. We want to solve the radical equation, the square root of x plus 5 minus 1 equals 3. So the first thing I want to do is I want to try to isolate this radical. So we need to get the radical by itself, which is called isolating the radical. Once we have the radical by itself on one side of the equation, we can square both sides, which will allow us to eliminate the radical symbol and solve for x. So I'm going to write the original equation. Then I'm going to add 1 to both sides, because what that will do is it will allow me to isolate that radical. Okay. That gives me the square root of x plus 5 equals 4. I can then square both sides of the equation, which gives me x plus 5, because the square root of x plus 5 squared is really the square root of x plus 5 times the square root of x plus 5, so I'm getting rid of that square root sign. And then 4 squared gives me 16. I then subtract 5 from both sides, which gives me x equals 11. Now, there are two ways to check this. The first way is by substituting x equals 11 back into the equation. The second way is to graph the left and the right side of my equation. So I'm graphing the square root of x plus 5 minus 1 and y equals 3. Okay. Both will show me that x equals 11 is a solution. So again, substitution method, I substitute x equals 11 back into my equation. So 11 plus 5 is 16. Square root of 16 is 4. 4 minus 1 is 3. 3 does equal 3. So that this is a correct solution, and it does work. Of course, you can graph them. So you can see that they are still connecting at this point of 11, x equals 11, y equals 3. Solve the radical equation, the cube root of x plus 3 equals 4. So again, very similar to what we just previously did, I want to isolate that radical symbol. So I'm going to subtract 2 from both sides of the equation. So that gives me the cube root of x equals 2. Now, instead of squaring both sides, because I have a cube root, I'm going to cube both sides, or raise both sides to the power of 3. That eliminates my cube root. So I'm just left with x equals 2 cubed, which is 2 times 2 times 2, or 8. Again, I can double check and ensure that this actually is a solution by substituting x equals 8 into my original equation and simplifying to see if the left and the right side equate to one another. I can, of course, also graph it. So I would graph the cube root of 8 plus 2, and I would graph y equals 4. So as we can see, they both do connect at one point where that x equals 4. Rewrite a formula. The suspension cables from a bridge's towers are further above the roadway near the towers and closer to the roadway near the middle of the bridge. So when I have like a suspension bridge, the ones that are closest to these towers that hold it up are going to be farther away from the actual bridge itself, while the ones that are closer to the middle are going to obviously be closer to the bridge. Okay. You can figure out your distance from the middle of the bridge, x, in height, and the height of the suspension cable, y, in feet, at your position by using the equation x equals the square root of y minus 220 divided by 0.010583. About how far is the cable from the roadway when you are 150 feet from the middle of the bridge? So the first thing that I know, I'm given the equation, x equals the square root of y minus 220 divided by 0.010583. And I'm given that the cable that I'm 150 feet from the middle of the bridge. So I need to figure out if I'm going to substitute that value into x or my value for y. So reading that second sentence, you can figure out your distance from the middle of the bridge, x, in feet, and the height of the suspension cable, y. So I'm given 150 feet from the middle of the bridge. That means I'm going to substitute 150 in for x. Okay. And I'm going to solve for y. So 150 equals the square root of y minus 220 divided by 0.010583. So I'm going to multiply both sides by 0.010583. So that gives me 1.58745 equals the square root of y minus 220. I'm going to then square both sides of my equation. And then I'm going to add 220 to both sides. So I get 222.51999 is approximately my y. So this tells me that the cable is about 222.5 feet away from the middle of the bridge. Identify an extraneous solution. So I want to solve the radical, the square root of 3x minus 2 equals x minus 4. So the first thing I want to do is I want to square both sides of my equation. When I do that, I get 3x minus 2 on my left side and x squared minus 8x plus 16 on my right. So again, I took that x minus 4 squared, so x minus 4 times x minus 4. I'm going to go ahead and FOIL it out, or you can use the lobster claw method, whichever method works for you. I subtract 3x and 2 from and add 2 to both sides of my equation because I want to get everything on one side of my equation and it equal to 0 so I can factor it. So I'm going to factor and set both factors equal to 0 and solve. So I'm looking for two numbers that multiply to get me 18 but add to get me negative 11. So the numbers that multiply to get me 18 are 1 and 18, 2 and 9, 3 and 6. 6 plus 3 would give me 9. 9 plus 2 would give me 11. So if they were both negative 2 plus negative 9 would give me negative 11. So those are going to be my two factors. So 0 equals x minus 9 times x minus 2. I set both of those factors equal to 0 and I solve. So I get x equals 9 and x equals 2. I want to always double check my solution to make sure that I don't have any extraneous solutions. So I go ahead and I substitute x equals 9 into my equation and simplify. I want to make sure my left side equals my right side. Okay, when I do that, I get 27 minus 2, which is the square root of 25. So square root of 25 equals 5. 5 does equal 5. So x equals 9 is a solution. I do the same thing with x equals 2. I get the square root of 4 equals negative 2. 2 equals negative 2. That is not a solution. So what this means is that I have an extraneous solution. Okay, so x equals 2 is an extraneous solution. It's a solution that I might get, but it doesn't actually work in my problem. Why do we get an extraneous solution? So the first step that we did was to square both sides of the graph, which means that I was getting a quadratic instead of a square root function when I squared the right side of my equation. Okay, so if I were to graph the original function that I had, that square root of 3x minus 2 and the x minus 4, they're going to connect and cross at 9, 5. When I squared it, I get 3x minus 2 and x minus 4 squared. So again, I have that quadratic equation. Now they're crossing at 2 points, at 2, 4, and 9, 25. So this means when we square both sides, they're not equivalent. Both graphs have an intersection point at x equals 9, but the second graph also has an intersection point at x equals 2. Squaring both sides of the original equation created an extraneous solution. Solve equations with rational exponents. What are the solutions to the equation, the quantity x squared plus 5x plus 5 to the 5 halves power equals 1? So the first thing I want to do is I want to raise both sides to the reciprocal power. So my reciprocal power, it basically just means I'm taking that exponent and I'm flipping it. So numerator becomes denominator, denominator becomes numerator. So instead of 5 halves, I would get 2 fifths. So I'm going to raise both sides of the equation to 2 fifths. That cancels 5 halves and 2 fifths. It cancels each other out. So I'm just left with whatever was left inside that parentheses. And 1 raised to any number is still 1. Okay. So I get x squared plus 5x plus 5 equals 1. I subtract 1 from both sides. Then I factor this. So I get x plus 4 times x plus 1. I set each of these equal to 0, and I solve. So I get x equals -4 and x equals -1. Of course, double check, go back, make sure that both of these are actually solutions and we don't have any extraneous solutions. So if I put -4 in, I do get 1 equals 1. And if I put -1 in, I do get 1 equals 1. So these are both solutions, -4 and -1. Okay, so there are no extraneous solutions in this case. What are the solutions to the equation x plus 18 to the 3 halves equals x minus 2 cubed? So again, I'm going to raise this to the reciprocal power. So 3 halves becomes 2/3. When I do that, the left side of my equation becomes x plus 18. The right side of my equation, I'm taking that 3 times 2/3 because it's a power to a power. So that means I multiply my exponents. 3 times 2 is 6. 6 divided by 3 is 2. So I get x minus 2 squared. Okay. I'm going to expand the right side of my equation. So x minus 2 times x minus 2 gives me x squared minus 4x plus 4. I subtract x and 18 from both sides of my equation and simplify. So I get x squared minus 5x minus 14. And then I'm going to factor the right side of my equation. So I get x minus 7 and x plus 2. So that means I get a solution of x equals 7 and x equals -2. Then, of course, double check, make sure that you don't have any extraneous solutions. So I put 7 in first. That does give me 125 equals 125. And then I double check for -2. -2 gives me 64 equals -64. So -2 is an extraneous solution. 7's my only real solution. Solve an equation with 2 radicals. Okay, so I have the radical equation, the square root of x plus 9 minus the square root of 2x equals 3. Since we have 2 radicals, we need to start by getting 1 by itself. Okay, so I'm going to subtract, add square root of 2x to both sides of my equation. And then I'm going to square both sides. So that gets rid of my left side, which is great. So I have 3 plus the square root of 2x times 3 plus the square root of 2x, which gives me 2x plus 6 times the square root of 2x plus 9. Okay. I subtract x and 9 from both sides, so I get 0. Okay. Then I'm going to try to get 1 radical by itself. So I subtract x from both sides. I'm going to square both sides to get rid of that radical. So -x squared is x squared. 6 square root of 2x squared is 6 squared, which is 36. And the square root of 2x squared is just 2x. So I get 36 times 2x, which gives me 72x. I subtract 72x from both sides. So I get x squared minus 72x equals 0. I can factor out an x. So I get x times x minus 72 equals 0. That means x equals 0 or x equals positive 72. Of course, you still need to check and see if there are any extraneous solutions. So I substitute 72 in. I get -3 equals 3, which is not a solution. And I substitute 0 in, and I get 3 equals 3, which is a solution. So I do have one extraneous solution of x equals 72. So x equals 0 is my only solution. Solve a radical inequality. The body surface area, or BSA, of a human being is used to determine doses of medication. The formula for finding BSA is BSA equals the square root of height times weight divided by 3,600. And my height is in centimeters and my weight is in kilograms. So a doctor calculates a particular dose of medicine for a patient whose BSA is less than 1.9. If the patient is 160 centimeters tall, what what is the weight of the person the dose is appropriate for. Okay, so I know that I have 160 centimeters, which is my height, so I can substitute that in for H, and 1.9 is my BSA. So I substitute those values in. So it did say less than 1.9, so I've got my formula is less than 1.9. Okay, I'm going to square both sides of my equation, so I get 160 times W over 3,600 is less than 3.61. I then multiply both sides by 3,600, which gives me 160 times W is less than 12,996. Okay, then I divide both sides by 160, which gives me W is less than 81.225. So the person would need to have a weight of 81.225 kilograms or less for the dose to be appropriate. And then summary. So you can always graph the two sides of an equation to ensure that you have the correct solution and that you don't have an extraneous solution. So again, when you're trying to solve these, you want to isolate the radical term, square both sides to remove the radical, solve the equation, and then eliminate extraneous solutions by double checking your work to ensure that the solutions are valid solutions. You can always substitute your answers back into the original equation to ensure that both sides are equal. If they don't equal each other, then that is an extraneous solution. Make sure to check all of your solutions that you found. And that is the end of Unit 5, Lesson 4.